I'll present to you some groundbreaking developments regarding meshing in ANSA. These major developments will significantly reduce the meshing effort, the FE model build time, and will increase the automation. I will start off with brief overview of motivation behind these improvements, followed by key enhancements in detail. Starting with mesh library for stamps. Stamps are very important features of a part and they have strict meshing specs. For instance, all stamps of the same geometry should be meshed with particular mesh representation. Also, meshing them is a demanding job. ANSA now offers a library where mesh representation for stamps can be saved and they can be automatically applied. Meshing a casting part is a difficult job, and in many cases, the part that is going to be meshed has many similarities with the previous part, or in other words, have only few differences. Inherent mesh functionality takes advantage of the similarities of the casting parts to make their meshing easier. This new functionality recognizes the areas that have not been changed and inherits their mesh, while creates the mesh for the new ones. Additionally, it also helps user to identify the areas that have been changed. Meshing a bulky part with hexes is a job that requires a lot of experience. The user must imagine how the model should be decomposed to smaller volumes that can be meshed with hexer. In many cases, taking a wrong turn at the early stages of this procedure may lead to a dead end. And then he must go back, reject a big part of his work, and do it again. MapBlock is a new ANSA tool that makes hexa meshing easier by automatically identifying the volumes that can be meshed or not, or have errors. ANSA has many upsides and a few downsides. One of them was its layout. Starting from the mesh, the layout has been redesigned. This new layout boosts the productivity and gives a more pleasant user experience. Let's talk more about ANSA Stamps Mesh Library. Here, we see same stamp meshed in two different ways. This perimeter may be preserved or not. If we choose to delete it, we get a side elements with uniform length. While if we choose to keep it, we get a more accurate description of the geometry. Also, the area of the corner may be meshed this way or this way. On a circular stamp, the mesh on the top may have different patterns. This top has a quartz and trias, while this top has been only meshed with quartz. On a bead, the user may select to have nodes run through its ridge or not, depending upon the type of simulation. On top of strict meshing specs is the fact that the stamps come in large variety of shapes. They may have rectangular shape or a circular shape, or they may be elongated. They have more complex shape. They may look similar yet have significant differences. And all these different shapes have also different sizes. Meshing of stamps in ANSA can be done using the batch mesh tool. The stamps are automatically recognized and meshed using predefined treatment rules. The problem with this is that due to large variety of stamps, shapes, and sizes, the potential to get any desired mesh representation based on only predefined meshing treatment rules is limited. So, ANSA has to offer one more thing, the stamps mesh library. The user must create mesh representation for each stamp geometry and save these mesh representations in the library. An important thing is that each stamp geometry may have more than one mesh representation saved in the library. Example, mesh for crash or NVH analysis, 3mm or 5mm mesh, etc. Now, having such a library, we can take our geometry that we want to mesh and feed it to the batch mesh along with the library. Batch mesh recognizes the stamps, finds the corresponding mesh representation in the library, and gives a mesh result which is perfect for the stamps. In these pictures, I marked the same stamps with the same color. Notice that all green stamps are the same and have the same mesh representation, and so on. Some more examples of perfect mesh on stamps using the library. Let's see the benefits of using Stamps library. Repeatability is achieved with the mesh patterns for the same features. Ability to create custom-made patterns per analysis. It can be built once and used for many other parts. This significantly reduces the manual mesh effort, and with the statistics, we can conclude that it takes 74% less time than needed. The next one is inherit mesh. Creating mesh for casting parts is not an easy task. It requires a lot of effort, time, and money. Here, you can see the relative effort needed to mesh the casting parts of a set of components. Something very common to have in the model is two parts that are very similar. They differ only on some few areas. For example, when a new product is developed, updated versions of each part are created. A previous and a newer version is a typical example of two similar parts. Another case that we may have two parts with only few differences. This case belongs to two different variations. For example, Cabrio, Sedan, EU version, and US version. Often, same component is located to the left and the right side of the car. And often, they are not identical, they have some differences. Also, a part may be symmetrical on its own. In this case, the right half is similar to the left half. Let's see some examples. Here you can see some differences that two similar parts may have. In the first case, the rib got a new shape, as you can see in the green area of the image. And this rib got a little bigger compared to the original one. In the second case, we have a new feature introduced completely. While in the third case, this feature was removed and a new hole opening can be seen. I'll also use this example to compare the older version and new version of the same geometry and show you how ANSA utilizes the similarities. In the newer version, the feature is moved a little bit, as you can see, compared to the other image. The rib is raised on one side. The feature is relocated and rib is lengthened. The curved rib in the new version has different curvature. This flange has bigger width. The hole position is moved a little, and the diameter of this hole was enlarged. Finally, this opening became smaller, and the radius of its corner fillets became smaller as well. These are all the updates that the new version has compared to the previous version. We can give this new geometry to the middle mesh generator and give the previous geometry and the previous mesh representation. The automatic result of the middle mesh generator is this. The mesh from the areas with no changes is inherited and all changes are shown in color coding. Using ANSA functionality and having the colors as guidance, the user can get easily the final mesh result, which in this case looks like this. The gray areas are the ones with inherited mesh. The blue ones are the areas with new or changed mesh. Let's discuss the benefit of using the inherit mesh functionality. Easily identification of design changes applied in new part version. Simulation results, reproducibility. Design wasn't changed, mesh shouldn't be changed either. This process is completely automated. Significant mesh effort reduction at version updates and takes 92% less time than traditional meshing. The next functionality is the map block. Creating hexamesh feels like a true puzzle. The user must imagine the part decomposed into smaller volumes that can be meshed with hexes. Then he has to actually decompose the part and hopefully not to end up to a dead end. The life of Hexamesher is now easier with the map block. This is the new ANSA tool that automatically recognizes which volumes are sweepable, which volumes are not sweepable, so further decomposition needs to take place, and which volumes, although are sweepable, have some errors that should be fixed before they'll be able to mesh with hexes. All these kinds of volumes are represented in convenient drawing mode. Let's see a bit closer how MapBlock works. The user has to use MapBlock to recognize the volumes and automatically create the appropriate shell mesh. Then based on the guidance of the MapBlock, he has to decompose the non-sweepable volumes using ANSA functionality. Recheck with MapBlock and decompose again until he has fully sweepable model that can be meshed with Hexa with the press of a single button. Please notice that at any time, the user may select to mesh his model with a different element length, and that is done 100% automatically. Additionally, if he wants to, the user can mesh one or more of the subvolumes with Tetras. The benefits of MapBlock: drawing of the model that makes it easy to follow the status and the errors of the subvolume. The mesh size can be easily and freely changed at any step of the workflow. Combination of hexapentamesh with tetramesh with zero effort can be achieved. It takes less effort compared to previous workflow, and 80% lesser time is needed. The next one is the mesh productivity. For starters, let's look at the classic ANSA mesh layout. There are 161 buttons in total, divided into two modules, mesh and volume. Having the buttons divided into two modules is annoying because the user has to go back and forth between the mesh and volume mesh modules. Buttons that will not be needed are in the first level of the interface. I do not need all buttons for each workflow or task, yet they are always present. The buttons are scattered, so it is difficult to know which buttons to press and with what order. For example, if I want to initialize this geometry and mesh it, I have to extensive mouse travel because I have too many buttons, a single button for each elementary task. In addition, I have to move my mouse to feature selection toolbar. Having all these downsides in mind, the mesh layout was redesigned in order to boost user productivity. Let's take a closer look. So we have different layouts now. As you can see, the buttons are organized into tool sets. A tool set for each workflow will be shown in the corresponding slides. The first one is for the shell mesh. This is for the middle mesh, tetra and hybrid mesh, and the straightforward working buttons are replaced with old-fashioned buttons, as you can see in the right side of the image. Also, obsolete functions are moved to the hidden menus. A new direct functionality is introduced for many functions from the mesh layout. Let's compare what we get from this improvement or enhancement. When compared to the classic mesh layout, where we have lots of buttons to pick from and the mesh functionality split into two modules, here with the new redesigned layout, we have less buttons to pick from, and all needed buttons are only those are present in each toolset. Buttons that will not be needed are in the first level of interface in the classic mesh, and they are difficult to know which buttons to press and with what order. In the redesigned mesh layout, we have a clean layout free from unneeded buttons, and they are easy to find. The classic mesh layout, the user has to do extensive mouse traveling. With the new design, it's very intuitive and very less mouse traveling. Some of the benefits of direct edit and new mesh layout. As discussed, a layout for each workflow, which is clean, easy, with no unneeded buttons that confuse the user. Straightforward, easier to learn approach for manual meshing, less mouse traveling, and of course, improved productivity. This reduces the time for a modeler to 10 to 40%. Now, I'll go ahead and show you some example, like a live demo on the map block functionality. So I'll consider this part which has to be mixed with hexas. Since this part is symmetry, I'll just take half portion of it. So I'll start with using the plane cut option from my topo mesh or topo module. Select the con and divide this component into two. The next step is to get rid of the half of the component. Now I'll proceed generating the hexa mesh for this component using our new functionality, which is map block. The map block functionality is available in the hexa mesh layout, which is in the solid mesh group. So I'll activate the map block function, select the component, middle mouse, and answer shows a legend on the left top corner which says non-mappable. It means that the component as is cannot be mapped. So this needs further decomposition. So I'll start decomposing the model by using some of the topo techniques. Firstly, I'll create a face around this feature. Similarly, here, once the faces are created, I'll intersect this face, the connecting faces. Now, once I make these changes, I can see that my legend has a new category which says need update. So to update this, I'll just right click and say update. So I have new categories which says mappable with errors. So in this case, I might have to further simplify this area. So I'll move to my hexa mesh module, hexa layout, go to areas and try to further simplify this area. Same thing on the other side. Now I'll again update my model and you can see that this areas changed to green, which according to the legend, they are ready to mesh. So I can hide these areas and work on the rest of the model. So this portion of the geometry needs further decomposition. I'll try to split these two areas into two different blocks. So I'll go to my topo again, use some topo functionalities like cut. And try to make a planar face here so that I can make a different block out of it. Using the loop option, I'll just fill this area. Furthermore, I'll use the project functionality with some options like paste and connect with faces activated. I'll project these cons onto this face to create blocks of these areas. Now again, I'll just update my map block. You can see that this area is also ready to mesh except for this portion. So I'll bring up the areas which needs further decomposition by hiding the ready to mesh area. In this case, I'll try to decompose this particular area by using the same project functionality. Topo to connect the cons. Re-update my model, and now we can see that everything is in the category of ready to mesh. Now we'll check the mesh flow of this component. As you can see that some areas the mesh flow is not so good. So I believe this needs some more simplification. So I'll go back to my topo, go to the project and try to decompose this further by creating blocks of components or blocks of areas in this region. Now I'll re-update the model, and you can see that we have a better mesh flow compared to the previous case. So once this is ready to mesh and I don't have any other categories which are to be addressed, I can just turn on my caps to see the areas which will be mapped. So just right click on the ready to mesh and say mesh, which will generate the hexes. Now I'll use the transform function to copy the generated hexes by doing a symmetry and using the mirror 3-point plane. I'll select 3 points to define the plane and create the fill component.